Good morning, good afternoon, and good evening. Thank you for joining us for today's IBM Tech Exchange webinar. I'd just like to go over a couple of housekeeping things before we begin. You should see a Q&A box towards the bottom of your screen where you can begin to submit any questions that you have for today's presenters. And later today, you'll be sent a link to the on-demand recording, as well as a link to access the slides, and a link to the IBM Tech Exchange community where you can connect directly with our experts. So without further ado, I will hand it over to today's presenters.
Hey, good morning, good afternoon, good evening, everyone. Today we're going to cover some things about Travis CI. Some of you may be well familiar with it from it being around for quite a while. It was, for a long time, one of the leading CIs in the industry. In fact, my team, probably about 6, maybe even 7 years ago, did a survey of all of the CIs that were in use on GitHub, and Travis was right at the top of the list. That gave us some incentive to go off and work with Travis to actually get back-end ports done for Power and shortly thereafter the Z platform. So we're going to talk a little bit about that platform. Most of today will be focused on a demo, a live demo, given by my co-presenter, Montana. Montana, if you wanted to say a quick hi. Give you the mic.
Yeah, hi, hi, I'm Michael Mindy, aka Montana. Been here at Travis CI now going on 5 years, and be doing a demo today of deploying multi-architectural IBM images to Red Hat's Quay using Travis CI.
So I think we're going to have some fun with this. There are a couple things I want to mention before Montana gets into this a little bit. I'm going to be talking more or showing more information about DevSecOps on our PDEX, our Power Developer Exchange community, which is also the host for this particular call. And this actually comes about from, in fact, I'm going to move on here to the second chart, a big push from the US government, but also governments around the world are looking for more visibility into what's in all of the products that they consume. And so there's a lot of formalization going on in the industry about how people build packages, how they scan them for vulnerabilities and that sort of thing. There's also a lot of work on how we do deployment, speeding up deployment and delivery. So I just kind of wanted to mention that Travis fits in as one of the components that you might see in orchestrating a DevSecOps tool chain. And so I think this is going to become more and more important to people over the next year or two as people try to comply with that government mandate. One of the things you'll see quite often is people break out CI/CD into a couple of different areas. Continuous integration people have been doing forever. I say forever. I started doing it in, 1992, 93, building an entire operating system for kind of like a Red Hat distribution, set up our own CI chain to build every night. And then since then, we've gotten more into continuous delivery, meaning building all of your deliverables at the same time. And then one of the things that Montana is going to show here a little bit is that continuous deployment, the ability to actually put your stuff where it's going to be consumed by your end users. And so some of you may recognize this is kind of a hodgepodge little chart about different components that fit into different areas here. The point of Travis, and there are several others in the industry as well, but the point of a tool like this is that they help orchestrate all of these stages. You can actually have call outs to do quite a few of these steps. So, one of the things that Montana will go into is not just the beginning here, how the source gets built, but all the way to the deployment into something like Quay. You might see quite often, I put this as kind of an inventory of all the tools that are out there. You can see quite a few components fit in here, from source code management through how you actually orchestrate your builds, how you do your testing, that sort of thing. Most people look at it as more of a pipeline view, where they may select the components from the previous chart for whatever stages are set up there. So the point is that most people, in fact, you'll see this for a lot of IBM products as well, we're trying to formalize and lock down what happens from the code creation all the way through the end of the process, where things actually get signed and delivered in a way that guarantees that we can, if we desire to, exactly repeat that build, or as close as possible. There's always a little bit of non-determinism in some of the tooling, but the goal is to be able to have a lockdown pipeline so that if you've got a source bill of materials for something, it won't change. If you've got a set of CVEs, you can check them and then maybe update your tooling, a year later to see if all of the same CVEs exist or if there are new ones that have been discovered, and that sort of thing. So the point of what we're looking at, or what Montana's going to show, is going to start kind of at the beginning here and wind up at the publication stage on the end. So with that as kind of an intro, I'm going to move on to Montana's component here. Montana, you want this chart? Or you want me to move right to the next?
We can move right on to the next here.
There we go.
All right. So let me share my screen here. Hope y'all folks can see GitHub. So let's go into some of the components that go into this multi-arc build that's going to be pushed to Quay. So we're going to go into the shell script that I made. So a couple of things here that you want to note is obviously exporting some of the experimental Docker CLI commands. We have a manifest here. So this is going to be really the child manifest for the IBM PowerPC builds, the S390X, also known as IBM Z. And you'll kind of see this is the image name, the multi-arc latest. And of course, here you can see where it's labeled PowerPC. And we're doing, obviously, the obligatory AMD. And it's really important, specifically when you're pushing to Quay, to make sure you have your environment variable set. And I'll kind of show you how to do that really easily in Travis really quick. So what we'll do here is we'll go into more options. We'll go to settings. And in Quay, you can make something called a robot account. And these robot accounts will talk to Travis and really talk to any service that you want. But in this case, we're using Travis CI. So these robot accounts will say, okay, we're getting from the build, we want these images, in this case, PowerPC and IBM Z. So let's push up those SHAs to Quay. So let's kind of just do that really live here. So we're going to go into Travis again. And we're going to actually restart this build. And while that build restarting, let's go through some of the build history to kind of see what this looks like. So you'll kind of see for the first one, you'll see that it's logging in to Quay. It's using the latest image of PowerPC. And then that gets pushed to Quay directly. And let me just kind of show you how that looks. So we're going to refresh. You can see I've just been pushing here 26 minutes ago. And you'll see here, there's kind of two things. There's Linux on PowerPC and AMD 64. This particular build, I'm putting a really emphasis on PowerPC, but in some cases, you'll see another little tux there that says S390X, and that would be obviously IBMD. So we'll see the child manifest here. And you'll see on some of the other images here that S390X has been built. And this is coming, again, mind you, all directly from Travis. So these are just coming directly from the .travis YAML. And to that end, let's go into the .yaml and see how this works, how I set it up. So we did distribution jamming. We're using shell for the language, and you'll kind of see really how the pattern works for Travis CI. It's very simple. So we got jobs include. So I've named the stages. So you'll see building PowerPC image, the AMD image, and then I start building the multi-arc image, which is combining the PowerPC and then AMD image together. And then we're also changing the permissage here using chmod plus x, and then just running the shell script. And then here, there's just a little script that I'm running, docker pull quay, and then that's my quay count, and then it's going to run that. And then after it runs it, it's going to actually just remove it. You could keep it, but just for the namesake of space, in this demo, we're just going to remove it after. And then you'll see the same exact thing for PowerPC. So let's see how the build's doing that I just pushed out earlier. All right, it looks like it's we're getting some progress here. So let's check on the multi-arc image. This one is still provisioning. Let's check out the first two. So this is the AMD build. Some things to note if you are pushing to Quay, you'll want to look at the worker information and some of the build system info. Some things that might give off that you didn't set up your configs right are versions of Ubuntu. So if you specify something like Jammy or Focal and you're seeing this number not right, maybe take a look back at your .travis YAML and take a look at it and see if you can't get a fix for that. But you'll see here, we're exporting those Quay robot users. These are the environment variables here that I just showed you how to set in Travis. This is basically the build script that's going. So we're pulling from the Ubuntu latest. This is from the Docker image. Now we're logging into Quay. And you see here, gives us a hash and it's pushed. And gives us a digest too, so we can actually search that in our own local CLI if we wanted to, using grep or something of your choice. So let's see here. It looks like now we've built the multi-arc image. So you'll see here we have the manifest now. We have the media type. We have the size, which is 529 megs. We have the architecture, which is the PowerPC. 256 hash. There it is. And then we also have the JSON as well. That also comes into Quay. Let's go back to the build and see how it's running on the x86, which is the AMD. Looks like it's still building. So here it is. You'll see hello world from a container running on x86, which means it was a successful build, and Quay is talking to Travis just like it should, and it definitely has detected that it's running on an x86 architecture. And so let's go back here and let's see how the PowerPC is going. That's still provisioning. And let's go back to some of my older build history where I have IBM Z, just to kind of show you how that looks like. So the ARC would be just same thing, S390X, building S390X image. You can go to build history here. Let's go back to down to one of that one. And then once say you wanted to, in this particular demo, the main demo, the IBM Z is not on here, but again, this would just say hello world from a container running on S390X. And again, this is directly talking to Quay. And it looks like my build just finished. Let's go to the PowerPC 64 LE image. And there you have it. Hello world from a container running on PowerPC 64 LE. So what we want to do is you want to go back to Quay. And you'll see my time, 8:12 a.m. So that means everything looks like it pushed correctly. So we're going to see if there's, we're going to check the tags here. And you'll see 2 minutes ago, you got PPC 64 LE and you got an AMD. We'll check out the child manifest here. And let's see some of the hashes, the manifest. Yeah, so just to make sure the architectures are here, PPC 64 LE and AMD 64. And in some of my older ones, you'll see that S390X was there. And this is kind of, you can kind of say kind of like the Docker file, so the security scans, the packages, but this is not part of that demo today. And let's go back to the actual GitHub repo, because there is some other things I'd like to go over. So let's go over the build script, because I think that's a little bit important too. So basically, when you've seen that it was saying, hello, I'm building from this arc, this is exactly how it detects that architecture. So it's going to tag that container, and it's going to, right here, this is where it's going to say, okay, what arc is that building from? And then from that robot user, it's going to push directly to Quay to my account /Montana. And then right here, it's just going, this is basically a default tag to detect the architecture. And then once we push it, that's exactly when it goes to Travis CI, and that's when you'll get the hello world. This is coming from a XYZ architecture. So this is just a very simple use case of Travis CI to IBM and Red Hat's Quay. But I have done a lot more complex things in Quay, and I think it's a really fascinating and actually a really useful way, specifically using some of the Quay robots. Let's see if I can do this without. So my email, my email address, montana@linux.com. So here's the robot accounts. And you'll kind of see here the bots that I have named. So you can name, you can have as many robots as you'd like, just given how many, let's say projects you have. As you can see, even 3 years ago, I was making some bots. This is the latest one, obviously. And it is important that these bots are actually relayed to your project. So for example, this description, it needs to be the same as it is in Travis. So let's see, for example, if we go to settings here again, you'll see, so the token that I have now, it's labeled robot token, robot user. And when you create a robot, it's going to give you a one-time generated password. So you have an option of saving that in a text file, or just, or saving it in Travis like I have, and having a text file so that you actually won't lose them. But if you do lose them, you can always regenerate them again in Quay. Secondly is the cron jobs. I haven't really made cron jobs for this specific build, but the nice thing is you can set cron jobs through the GUI in Travis, and it will actually just push to Quay through a cron job without actually having to do any work or making a cron table. So I think really it's a whole automated process from really zero to deploy using the IBM infrastructure to Red Hat Quay. So I think that's pretty much how simple this demo is, and really how simple it is to get set up. So yeah, back to you, Garrett, if you have anything, or any Q&A maybe.
Yeah, I've got a few things that I do want to mention in addition to this. So what Montana's demonstrating right now, this is a capability we've actually enabled for the public Travis CI. So if you've got a project on GitHub, as an example, open source, you can clearly use Travis. You could build for any of the three architectures. They also have an enterprise offering, or a cloud enterprise offering. So you can actually have your own isolated account at Travis, use still their cloud capabilities. And one of the things that IBM does is we have the Travis CI on-prem, and it's connected to our internal GitHub, which is how we do for a number of projects. We do all of their daily or local builds. We do some level of CD, be it continuous delivery, continuous deployment. So kind of what we're showing here is an example of the capabilities. You can get them from any of 3 different ways, and it's pretty flexible. We're actually doing another project. I don't know, Montana, if you've seen this one. We're working with one of his cohorts at Travis on trying to build all of the build scripts for Power. And I don't know how many of you are familiar with those, but
yes. We've
taken about I forget what the number is, something like 5,000 open source packages that we ported, and we're working to get Travis to be building those 5,000 packages on a regular basis for us. So, in a lot of cases, we would prefer that things be upstreamed. Some people upstream use Travis, which is great. Some people use other CIs. The one that has the best support today for Power and for Z is clearly Travis. Jenkins also works. You see a lot of Jenkins used, but it's kind of out of date compared to some of the more complex uses that that Travis can handle.
Yeah, and I would note so. For the 5,000 packages you were kind of referencing, with the open source or the SaaS model that we have, you can do something called like nightly builds, and again, this kind of falls back on the cron job. So really, Travis CI is as flexible as you want it to be, and specifically with the IBM infra. And as Garrett stated, when we're talking about IBM Z and PowerPC, no bias here, but it personally is, I think, one of the most flexible CI/CD products out there for these architectures, and definitely for the more complex things you'll be doing with these architectures. So that was a good point, Garrett. And again, just wanted to also hit home that this is a very basic just use case of it. These pipelines, we could have also did another stage that pushes up to AWS or something like that, or maybe IBM Cloud. It just really all depends on what you want to do, but it is possible with Travis CI, just given the pure flexibility of it. So I think that's just important to remember going in, that there's not much you can't do with Travis when it comes to these architectures. It's just mainly either getting support from myself, reaching out, so I think that's one of really the beauties of Travis. And we have a pretty simple GUI. We can simply store the environment variables, and then easily talk to Red Hat's bots that I've set up. And I think that's something that's just is very important, specifically when you're maybe under a time constraint or under pressure to get a deadline done or something. I think the IBM architecture and Travis work in tandem and hand in hand. So
I'm going to put you on the spot, Montana. You can
Yes.
decline this, but do you have an example of a more complex Travis.yaml that you could kind of give a view of that shows a few more stages in there?
Sure.
This is good and simple. All right. Take something maybe a little bit more complex. And while you're searching for that, I'll mention a couple of things. There's some things that I meet with the Travis team pretty frequently, at least every couple of weeks, and I even learned a few things over the past few months. That we see Travis linked into GitHub and GitHub Enterprise, but it also links into things like GitLab to SVN to Perforce to Assembler to Bitbucket. So Montana was talking about the flexibility. There's flexibility in terms of what the underlying source code management system is. There's flexibility in terms of what kind of scanners you might want to use. For instance, we've been using Trivia a lot. Some people use Aqua.
Coveralls, Sneak.
Lock. Yep.
It goes on and on.
Right. So the fact that you can plug in any of those things is actually quite handy, shall we say.
Yeah, and one of the good things is, I think, to remember, and then I will get to this a little bit more complex IBM multi-arc build, is you can plug and play really any of the things you've just said. And the flexibility of Travis is you can put it, say, in a before script hook. So and say, hey, fetch Sneak, and then run Sneak and run the code scanners. Or if you're running, say, something like coveralls or CodeCub, you can just really define those in services and then kind of run them at the end. And then, that will do kind of the same thing. So I think, again, that's kind of the flexibility of Travis and kind of the beauty of it. All right, so here's a little bit more complex one of a .travis YAML. So this is using a matrix. And actually, we're building some Python going on here. So we've defined the OS Linux, what distribution. So we're using PowerPC. This is doing a Python hello world script. So we've cached our paths, and we've defined those paths for the environment variables, which by the way, and just a pro tip here, that will speed your builds up exponentially. So I think it's always important to cache your directories and cache your builds. So just something to remember. And then you can actually, even before you install, let's say, so in this case, we've skipped the install, but let's say this script was installing, something that had a lot of Python dependencies. Before that install, you could actually say, I want this to check if it's going to actually pass for an AWS deployment, or really just anything, in Azure deployment, whatever you could think of. And a good thing that Garrett just reminded me of, obviously, was just the code coverage. The code coverage can also be used for before install and then after before install. So if you're running something like a linter, or you're doing a unit test outside of the matrix, these are two things that you can also do. And that kind of goes back to the flexibility. But in this case, for IBM, we're doing a dual IBM build here, and we're using Python 3.7. And these would run in tandem. Once they're built, they're using the infrastructure we've defined, which is the IBM and PowerPC, which I think is beautiful. And let's see if we don't have any more even more complicated ones for you, Garrett, because I think you like these here. Let's see.
And while he's looking, we've done a lot of kind of more complex build scripts. One of the things we run into, as an example, when we're building product, we like to look at the source bill of materials and the CVEs that are contained within the end result of the container. So we like to be able to build those as part of the pipeline. Being able to do that in Travis has been really handy, right? It helps us to get upfront knowledge about what components are in there, and also Travis gives us the ability to kind of build. I think Montana was showing this a little bit, but the implications are a lot broader than what he was showing. That you can build in stages, and so one of the things you see is that we'll sometimes have to build some intermediate components. Like we did something recently, I think it might have been Envoy, depends on Bazel. Bazel's not part of some of the base images, so you build Bazel first, but you don't want all the artifacts there. So you build Bazel in one stage, and you keep the binaries from it that you need to build in the second stage, but you don't then include that whole build environment in the container of your own personal application that you're trying to deliver. So this multiple stages allows you to kind of select what moves forward into each of the next stages, which is kind of handy. So it's
extremely handy. And yeah, to your point, this is a really good transition, actually. So let me zoom in a little bit here. So in this example, so we're going to be just using two architectures here, which is the PowerPC and IBM Z. So you can inspect a manifest. So I called this the cool IBM test because I'm not that creative. I'm a software engineer. So the cool IBM test will kind of show you exactly how the dual builds or the concurrent builds work in a .travis YAML. So this will give you the digest if you actually tell the .travis YAML, and I'll go back up and show you how we do that. To list the digest, to list the architecture, the media type, and again, the digest. So we have Z, and then we have the PowerPC here. And then, so we have right here, we're creating the manifest, and one can assume, and this is just in the demo, we can assume this, let's just say this is S3 or IBM Z, and this is PowerPC. And this is kind of how it looks when you're having some success, some failures, and you're just kind of working through it. But so let's go up into this .travis YAML. This is a lot. Let's see here. Let's go to .travis YAML. Okay, so in this particular build here, so we have a build script here, and this is going to be important to remember because right here, we're defining PowerPC 64, and we want it to be a running node. And so we want some verbosity on that build. So when that happens in the build config, and in fact, I can show you that after in the Travis UI, you can see exactly really what's going on with just basically step by step. So we did this with S390 or Z Python, and then you'll see the Java JRE, which is classic. And so let's go back here. I have this on a cron job, so let's go to details here. This build is passed. So you'll see here, so PowerPC 64 LE node. And you'll see this will give us the schema v2 of the manifest, the type of config that I did, the size, which this one's fairly big, the media type. And again, this is all just for PowerPC node. Let's do the IBM Z Python. And again, this will tell us architecture, what operating system we're running on. And again, remember, this is all within Travis CI. So as to Garrett's point, we're running about we're running about 6 IBM architectures and variants combined in tandem and in parallel. So I think things like that, like I was saying, when you're under kind of time constraints or you want to just do things, just really in parallel and just do it more than once, I think this is the perfect way to do it. One last thing I would like to actually point out is the JREs here. These are classic IBM packages. And if you go to verbose here, you'll see kind of the ref here, which is docker.io. And these are something that you can either fetch from Quay or Docker Hub. And actually, this whole repo that really is a lot more complex than the demo I did show today. To go through it would be pretty complex, but you can fetch it and kind of go through it. And I will make sure to provide a link after the fact. But yeah, so this here is a great example of running various IBM architectures at the same time, and at the same time getting all the information that you need from each build from A to Z. So if there's anything that breaks, easy to fix, because what will obviously if it'll pass or not. I think I think this is a perfect example of what Garrett was talking about, running different architectures, specifically IBM ones, in tandem. So in Travis CI. So
and part of this brings up another point. Almost the only thing that we ever had to do from a user perspective was to add the arc tag inside of the Travis.yaml. Most of the rest is actually handled because either IBM or Travis built some of the infrastructure behind it. We provide the basic images that you run on, be they whichever version of Ubuntu is typically what's out there. It all runs inside of an LXD-based container. Yep. So you've got some level of isolation there. But it's all identical to running on AMD. In fact, I think it's even simpler. You've got support in there for running on Mac OS, I think, in your public Travis, right? And others. And I think they've got a few more changes than what Power needed in terms of language spec and that sort of thing. So, if you've used Travis, support, using it for building on Power, for deploying, for creating multi-arc images, for provisioning them or deploying them, it's got it all. And it's identical for the Intel side.
Yeah, absolutely, Garrett. It is totally identical to the Intel side. And what you'll see here is this bash script that I created. So I'm really here just defining PowerPC and IBM Z. And the good news about this is you can actually reuse this script. So in the .travis YAML. So if, for example, So you'll see here we have some variants here, and I leave these blank because it'll go through all the variants. And this was I didn't expect to do this demo today, but this was for at one point a demo purpose that I never did, but I'm doing it today, which is actually great. So you could actually put variant Python, variant Node, but if you leave them blank, it'll actually show all of the variants. So if you want to know what's out there, it'll actually print it out. And one thing to note is you'll want to enable the Docker manifest, or if you're using Quay or say something like Podman, same thing. You'll want to enable it, and specifically with Travis, you'll want to push the latest manifest, whatever that may be, with your build. And let's go back here to kind of that build sh file I was talking about, and just in the beginning here, you'll kind of just see how these are kind of left blank, either for you to define yourself, or kind of just see kind of what's out there, using it kind of almost as a search function. And let's go back to the .travis YAML file really quick to show you how I kind of use this travis.shell and build.shell. So this is kind of how I use them, but let's say that you needed to use this up here for some reason, and you can reuse it again down here. So I think just with that, I think, reusable and recyclable shell scripts in the .travis YAML is extremely important thing to note, and kind of a quote unquote pro tip. And secondly, when doing it with IBM's architecture, you're going to be getting a lot more information, specifically when you have things tags like verbose and insecure that some don't offer. So I think that's really a big help, and really a big function that the IBM architecture offer that some don't. So that's just something to note.
Cool. So I'm going to make a pitch. Portia made this at the beginning as well. We haven't seen much for questions, but I'm going to give you a couple of minutes to try to stump one of us presenters. If you want to add any questions in the Q&A interface. We love that level of interaction. We want to know what you guys are actually interested in, whether or not we're getting you the information that you want. One of the things I will add to all of this, as I kind of said at the beginning, this whole secure supply chain DevSecOps space is, I think, becoming more interesting to everybody. It's becoming critical for my team to be able to build both the products that we contribute to, as well as the open source ecosystem. And so more and more integration with some of that tooling has been absolutely critical. Go ahead, Montana.
And as you mentioned earlier, Garrett, obviously the government, the U.S. government as well, and other governments around the world. So I think you hit the nail on the head on that one.
Yep, we're all kind of, I don't know if I want to say reeling, but we're all trying to adapt to their requirements, which I guess I have to use one of my favorite old jokes. There used to be a saying that said, if carpenters built houses the way that software developers built software, the first woodpecker to come along would destroy civilization. Now, you have to internalize and unpack that a little bit, but it basically says historically, and I think many of you, if you're software developers, have seen some of this. Software development has gotten away with a lot of sins over the past many years. And we spend a lot of time trying to now get ahead of some of those. We're trying to do more of these checks. We talked about coveralls, we talked about code coverage. Those are some pretty basic ones. We're now doing some stuff that, looking for CVEs and CWEs. The more that all of this stuff is integrated into the pipeline, whatever pipeline you have, the absolute best overall. We do have a really important question. Oh, wait, it just says Montana rules. So cool.
Thank you. Whoever said that. I can't see your name, but thank you.
Yeah, it's probably one of your fans, one of your many fans.
No, I'm kidding.
Yeah. But thank you. That does at least prove that our question question facility does work, so appreciate that. I don't see any other questions as yet. I think we've kind of covered the basics here. I'm going to show us our last chart here. If you want to get a hold of me, I could have put my email in here, but I actually prefer if people interact on the Power Developer Exchange, because I'm slow. I'm getting old. It takes me longer to get to all of these, and it helps when I've got a lot of friends that can actually look at your questions as well and get them answered. So that little QR code will take you back to the community page where this was posted. I would strongly encourage you to add questions, especially if you got stuff on secure supply chain. I've been playing with this all this past year or a couple of years. I've got a lot of insights if you want to know how to do some of that on Power. If you've got questions on Travis specifically, we can handle them there, or Montana has graciously offered to accept the thousands of emails that you're going to send him and respond diligently to every single one,
Absolutely.
I'm sure.
Within 5 minutes, that's the guarantee that I will give everybody.
Or
you
your
heard
money
it here
back.
first. Or your money back. Thanks, Gary.
So with that, I think we're pretty much at the end. Any last words, Montana?
No, other than, you really make a good point about the secure supply chain and, SBOM. I think, of course, this falls in the compliance with a lot of things. And, I think that's definitely going to be, something that's going to be improved as kind of like, the months, years goes on, as we were saying, by all sectors, including the U.S. government. So it did, again, hit the nail on the head there. But if you have any questions, feel free to email me at montana@travis-ci.org. I'll get back to you as soon as I can, and or the questions internally with Garrett, and then I can also get to those if it's maybe regarding SBOM or something like that, or signatures for your builds to make sure that your log scan is passed, or maybe what even questions down to what is the best code coverage that works with Travis CI or something, in my opinion. So
cool. All right. Well, I think that without further ado, Portia, I think that brings us to the end. Thank you, everyone, and have a great rest of your day.